Here's integrated 2. It's 1.1 problems 5 through 9. So in these kinds of problems, they're asking you to graph some functions, and these are absolute value functions, and they want you to compare the graph of the given function to the graph of the parent function, which is f of x equals absolute value x, and describe the domain and the range. So if you're just giving me a graph that looks like a V-shaped, and you're not using your graph paper to show the intercepts and the slopes of the lines, that's not good enough. You have to be able to present a full graph. So let me get this a little closer. There we go. And so this was taught on page 6, and this is the vertex form of an absolute value function. So they have that the function is a times absolute value x minus h plus k, and a, h, and k are parameters. A is a stretch factor, a vertical stretch factor, or a vertical compress. H is horizontal shift, left and right. K shifts it up and down. You may not know this until you actually read all, everything on page 6 and page 7. And then on page 8, it asks you to draw these graphs and compare them to the parent function and describe the domain and range. So first of all, the parent function is y equals absolute value of x, and so it's a distinctively shaped function because it looks like a V-shaped function. And I always like to use -1, 0, and 1 when I'm plotting points for a graph, if I can. So you'll notice if you plug those in, then you get -1, the absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1. So you get something that, I'm counting by ones here on my scale, you get something that is a V-shaped. And so you don't have to write all the numbers in, like this is 1, this is 2, this is 3. I just need to see that you're counting by, like that you're paying attention to what you're counting by on your scale on your x and y. This is 1, this is 2, this is 3. Okay, so I'm counting by ones. So it's going to go up, it's like a slope. It's going to go up 1 over 1. And it's going to, this is the parent function. We call it the parent function. And this is y equals absolute value x, and this is the one they want us to compare each one of these graphs to. So for instance, on number 5, they've got absolute value of x minus 4. Well, I know the minus 4 is going to give it a vertical shift, and it's going to go down by 4. So I can just tell by looking at it without even plugging any points in. I can tell that it's going to look just like the parent function, but it's going to be moved down by 1, 2, 3, 4. And it's going to have the same shape. It's going to go up, up 1 over 1. Like that. And by doing this, I'm actually giving a proper graph that has points on it. Because if I just draw a random V shape on my paper, that's not enough to be a sketch of a graph. You need to, at least to have some intercepts. And if you look at these, -1, -3, that's just me plugging a number in. I plugged in -1, and the absolute value of -1 is 1, and 1 minus 4, it's -3. You can always plug these numbers in. Okay, and they should actually appear on my graph. So when I looked, the graph that I got, when I looked at it, if I plugged a number in, it didn't appear on the graph that I was given. So this one should, -1, -3. See what I'm saying? So you need to make your graphs more precise. So this one is, oh, and then did I answer all the questions? Well, I showed the graph, and now I need to answer how does it look compared to the parent function. I'm going to say it's shifted down by 4. And what's the domain and the range? The domain is the x values. So basically, now that I have the graph, I can just look at the graph. From left to right, since the arrows point out in both directions, the domain is all real numbers. So I'm just going to say all real numbers. And the range is all the numbers higher than -4, right? Like if you look at the way the graph goes vertically, there's no points of the graph that are lower than -4. So I can just say y is greater than or equal to -4. So these are all part of my answer. Okay, so I have to give a full answer. This one, I know just by looking at it that this is going to be shifted left by 1. So it's just going to be the parent function, but shifted left by 1. It's still going to have the same slope, if you will. So it's going to look like this. I already know that because I know that the numbers inside the absolute value bars give me a horizontal shift because that's h. That's the parameter h. But if you're not sure, then you can just plug the numbers in. -1, 0 better be on my graph. It is. 0, 1's on my graph. 1, 2. And if I wanted to get some more, I could put -2. Well, -2 in there would give me a -1. Absolute value of -1 is 1. See what I'm saying? And then so on this one, I would say shifted left by 1. And the domain is all real numbers, and the range would be y is greater than 0. Okay, so these are some examples of how your work should look when you turn it in, when you do your work. The last one is, I mean, there's more, so I'm going to have you actually do a couple of these correctly and resubmit them. So this is 1/3 times absolute value of x, so that should give me a vertical compression because that's the parameter a right there. So I plugged some numbers in. I know I'm going to have a 0, 0. I'm going to have a -1, 1/3, and a +1, 1/3. And if I want to plug some more numbers in, I feel like -3 would be a nice number to plug in, because if I put a -3 in there, that's 1/3 times 3, and that gives me 1. Actually, yes. And if I plug a +3 in there, I also get 1. So then you'll see. Now at least I have some points on my graph, and you can see that my graph, this is vertically compressed. From the parent graph, and then the domain is all real numbers because the arrows go in to the left and the right, but the range is just greater than 0. So go ahead and try those again.